lesson we're going to look at a cyclic quadrilateral, and the circle theorem is that if we have a cyclic quadrilateral, the sum of the opposite angles is 180 degrees. Okay, so first of all, what is a cyclic quadrilateral? A quadrilateral has four sides, and it becomes a cyclic quadrilateral when all four corners touch the circumference of the circle. So, for example, this is not a cyclic quadrilateral because only three of the vertices touch the circumference of the circle and this one doesn't. So this here is a cyclic quadrilateral because all four vertices touch the circumference of a circle. Okay, so let's do some questions to see how we can use this property to find some unknown angles. So we're being asked to find angle x in this case. Okay, hopefully we can see that we have a cyclic quadrilateral here. And that tells us straight away that this angle here is 60 degrees. Let me just say that angle CBA, I'm going to put a little hat on the B, is 60 degrees. Notice how I've lettered those. It's CBA, and that's that angle. You could have written it as angle ABC also, as long as the B is in the middle there. That probably should be more of an angle there than a letter L. Okay, so that's 60 degrees. We might want to put a reason, and we would say opposite angles in a cyclic quadrilateral add up to 180 degrees. As long as we mention opposite angles, cyclic quadrilateral, and say that their sum is 180 degrees. So we have this angle here is 60 degrees. Now we're going to use another circle theorem. If we notice, this here is a diameter because it goes through the center of the circle. And we've got a triangle actually that's been formed here. And we have another circle theorem that we've looked at, the angles in a semicircle, and we know that that is always going to be 90 degrees. So in fact, when we add x and 60, they must add up to 90 degrees because this is already 90 degrees, and the angles of a triangle add up to 180. So x must be 30 degrees. Okay, in the figure, we're given AC as a diameter with a center O. And we're told some of the angles, and as you can see, those angles there. Okay, we're being asked to find angle ACD. So let's write that there, ACD. I'm going to put a little hat on the C. Let's find that angle. So ACD, so that's that angle there. Okay, since this is a diameter, we know that this must be 90 degrees. Therefore, these two angles must add up to 90, so that's actually going to be 55 degrees. So angle ACD is 55 degrees. Then we're asked to find angle ACB. ACB, that's that angle there. And we can use the same property again. Since this is AC is the diameter, then this angle is 90 degrees. So therefore, that angle there is 50 degrees. So we now have that angle ACB is 50 degrees. And then finally we're asked to find DAE. So that's this angle here, DAE. So here we want to use a property of the circle theorem that we have a cyclic quadrilateral, and if you notice we have a cyclic quadrilateral which is this one here. So let me just write that. So AEDC is a cyclic quadrilateral. And we know that this angle here is 55 degrees, so we know that AED plus 55 must equal 180 degrees. Why don't I call that angle Y? So Y plus 55 must equal 180 degrees, so Y is 125 degrees. We weren't asked to find that angle, we were asked to find angle DAE, but we have this triangle, that's 30, that's 125, and so we've got to find, let me just label that, that's E, D, A, and we've been asked to find angle DAE, and the angles of a triangle add up to 180 degrees, so you've got 125 plus 30 plus the unknown, I'll call that y, no I won't call that y, I'll call that x, and that must add up to 180 degrees, 125, 155, so x is actually 25 degrees. Okay, a bit of algebra here. We do have a cyclic quadrilateral. Notice this shape has 4 sides and all 4 corners touch the circumference of the circle. So we can say, we've been asked to find all the angles, so let's find x and y. Let's do y first. So these 2 angles here are the opposite angles in a cyclic quadrilateral, so they add up to 180 degrees. So 2y plus 4 plus 4y minus 4 is equal to 180 degrees. Just solving that, 6y is equal to 180 degrees, so y is in fact 30 degrees. Okay, now it asked us to find the angle, so if let's look at this angle here, that's 2y, which is 2 times 30, 60, plus 4 is 64, and this angle here, angle C, is 4 times y, which is 120, minus 4, which is 116. We've got those 2 angles, and then we've got these 2 angles. They're opposite angles in a cyclic quadrilateral, so they also add up to 180 degrees. So 7x plus 2 plus 6x minus 4 is equal to 180 degrees. That gives us 13x minus 2 is equal to 180. Add 2 to both sides, gives 182. And divide by 13, 13's into 18 goes once with 5 remaining and goes in 4 times. So x is equal to 14 degrees. We weren't asked to find x, we were asked to find the size of the angles. So we've got here 6x minus 4, while x is 14, 6 14s are 84 minus 4, so that's 80 degrees. And I think that should come out to 100. Let me just check. 7 14, 7 times, just quickly, 7 times 14, quick way of doing that is 7 times 7 times 2. That's the 14 there. 7 times 7 is 49, times 2 is 98, and then plus the 2 is 100. Okay, we're given that ABCD is a cyclic quadrilateral and their diagonals are intersecting at the point P, and we're given certain angles. Okay, often in circle theorem questions I like to just fill in what I can see and then see what the question is actually asking me. So I can see that here we have this angle is 40 degrees. Now notice it's taken that chord, that angle there, or you could say it's taken this segment. But can you also see that this chord here could have been made by this here? So that's also 40 degrees because that's angles in the same segment. In a similar fashion, this is 60 degrees here, and 60 degrees makes this chord or this segment. So could that same chord or that same segment be made in another way? Yes, it could. It could be made that way. So in fact, that there is 60 degrees. Okay, is that going to help me to find, what have we been asked to find? Angle CAE Okay, CAD, I've already found it. So angle CAD is 40 degrees. And BCD. Now BCD is this angle here. And it's the opposite angle in a cyclic quadrilateral to this angle here. And that angle is 100. So this must be 80 because they add up to 180. So angle BCD is 80 degrees. Okay, I'm glad I got this question in because it uses a couple of the circle theorems. If we notice, this here is a cyclic quadrilateral. But we also have an angle at the center. Now if you remember, the angle at the center is twice the angle that's here. So we can actually say what that angle is. So we want half of this, and that's just x plus 14. So this angle here is x plus 14. So we can now look at these two angles, which are in a cyclic quadrilateral, and say that they must add up to 180. So let's do that. X plus 14 plus 3x minus 70 gives us 180 degrees. 4x, because we've added the like terms, and then 14 minus 76 is negative 56. Notice just about the column of equal signs, they're going to add 56 to both sides to leave 4x, and that gives 236. And then we're going to divide by 4, 23, so 5 with 3 remaining, 59 degrees. So x is 59 degrees, and that's actually what we were asked to find.